Hi, welcome to the Shiko Math Lab Fun Probability Problems Solving section. So today, we're going to try to solve a probability problem. It's a very classical type of the probability problem, toss a coin. So in this situation, we have a fair coin is tossed 5 times here. That means I'll get a half and a half chance to get a head and the tail. Now we're going to solve this 5 problems here. All right, so the first problem here is what is the probability we are going to get the first is the head and the second is the tail. Okay, let's go ahead and get started here. Okay. Okay, so in order to solve the problems here, the first, let's take a look at what is the total number of the elements for the sample space here. So I will use this notation is in N and the S here. S is represent a sample space. So the total number of the sample space, since we have 5 fair coin, a coin tossed 5 times, so each toss you have 2 outcomes. So the total sample space will be 2 to the 5th power, right? So I'm going to have a 32 possible situations here. Okay, so the part A, let's say, what is the probability I'm going to get the first is the head and the second is the tail. So basically I'm finding the first is the head and the second is the tail. Okay, so I typically like to draw a simple graph here. So this is 1, 2, 3, 4, 5, right? So here, just tell me the first has to be a head, and then the second has to be a tail. Now afterward, I don't really care, right? So you can have anything. That's what is the first is a head and the second is tail. So I know in order to get a head, it's 1/2, right? And because they are, they are tossed, is independent toss. So to get a tail is also 1/2. So what is the probability here? It's 1/4 here. Okay, so then the part B is here. They said probability no head, no tails. So no tails. That means, in here, no tails. That means for this file, I'm getting, sorry here, no tails. That means I'm going to get a head, a head, a head, a head, a head. That's the only situation, right? So that's why the probabilities here going to be no tail. I only have 1 situation out of the 32. So this is the 1/32 because I only have 1 situation, so 1/32. Or you can say because the head, right? So it will be 1/2 times 1/2 times 1/2 times 1/2 and times 1/2. All right. Okay, so part C is here is at most 2 heads here. Okay, so this is a probability at most 2 heads. Okay, so at most in here, we see this frequently in the probability problem. At most, that means it cannot be more than 2 heads here. So basically, I'm looking for the probability x is less than equal to 2, right? So where the x is equal to the numbers of what? Numbers of heads here, okay? So here, so basically you can say that would be the probability x equal to 0. That means 0 head plus the probability x equal to 1 plus the probability x equal to 2. Okay, so probability x equal to 0, like we talk about the no, the no head is all tail, so it's 1/32. Okay, now in here I have 1. Okay, so 1 of them can be head. That means like this, right? So I can have any 1 of them. So I can have here is the head and then the remaining is the tail, or the head can be in any positions here. So this is kind of like the binomial distribution, right? So for the 5 position, I take 1. And this one is my head, so it's 1/2. Then for the remaining 4 positions, what is 1/2 to the 4th here. So this is the remaining position. This is the tails, right? And this is what? This is the head here. Okay. So also we can have an x equal to 2. That means in here you can need to choose the 2 positions to give the, to be a head. So it's by the binomial, we can say 5 take a 2. Then this is 1/2. Then this is the square. The reason why it's a square because I need to have 2 positions of head. Now what is remaining here is 1/2 to the 3rd, right? So this 3rd here is because for the remaining, I need to have 3 tails here. Okay, so if you put into if you calculate that out, this will be 1/2. Okay, now part D here. Part D here is I want to find the probability first head. In the first 3 attempts. Okay, so the first head in the first 3 attempts. So let's take a look here. That means in here I have first 3 attempts here, right? So the first head happened in here. Okay, so that means my head could happen here, right? That's my first set. It's the first attempt, 3 attempts. So after that, I don't really care, right? Okay, so also my first head could be in here. Also, like here, my first head can be here. So if this is my first attempt, if this, oh, I'm sorry, here should be head instead of tail, right? So it's a head and a head. Okay, so for the first ones here, the first head is in the first 3 attempts. This one is okay. So for this situation, it's 1/2. Correct? Then for the second ones here, that means my first one has to be a tail. After that, I get my first head. I don't care what is the remaining here. So those is doesn't matter anymore. This doesn't matter anymore. So what is the probability here? The probability here will be 1/2 times 1/2, right? So it's 1 tail. And then in here, so the same things here for this ones here. When my head is in here, that means I have to have tails here. Now, whatever after doesn't matter. So for this probability will be 1/2 times 1/2 and times 1/2 to the head here. So what is the probability? Will just be I add these 3, right? So I will add these 3 together. So this will be 1/2 plus 1/2 times 1/2 is 1/4. 1/2 times 1/2, this is 1/8. So what is the probability I'm having here is the 7/8 here. Okay, it's getting more interesting here, right? Okay, so now part E is here. We want to find the probability no 2 consecutive. Okay, no 2 consecutive heads. And the first is a head. Okay, so let's take a look at this situation here. Okay, so let's do a simple graph here. Okay, so 1, 2, 3, 4, 5. So they said that here, the first one has to be a head, right? So and the first one has to be a head. So I know my first one has to be a head. And then they say no 2 consecutive head. So I know my second one cannot be a head. So the second one has to be a tail. Okay, So now I'm having the remaining three positions because if my second one is a head, now I already have two consecutive heads. So I know my second one has to be a tail. So now I have three positions left here. So no consecutive heads here. So what I can have here, okay, so let's see here, because I have threes, right? So I'm going to have how many here? I'm going to, okay, so 1, 2, 3. So I'm going to have 8 possible situations. One, two, three, four, 5, 6, 7, 8, right? Because it's each one have two possible, so 2 to the 3 is 8. So I have a possible, a situation. So here I can have a tail, tail, tail. Okay, so I know every time if I have a tail, 2 tails, then I will be fine here, right? So then here this is a head, and this is a head, and this is a head. So all this one will be a good situation. Now also I know for the last situation is a head, head, head. For this ones here, I cannot have this. So we know this situation is good, this situation is good, this situation good, this situation is good, right? Okay, so then for this ones here, I know I cannot have a head, head, head. So now also I know for the two head situation, you can have this one, or this one. Okay, so now in here, this is a tail, this is a tail, this is a tail. So for here, I know this one's here. This one is not going to happen because two heads are going to consecutive. This is cannot be happen. This is cannot be happen. So now I know I have this one, this one, this one, this one, this one, right? So I have 5 possible situations. And because it's always half times half, right? So for each one here, the probability is 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So it's 1/32 here. But I have 1, 2, 3, 4, 5. So the overall probability will be 5/32 here. Of course, in here, because this is the fair coin, so that's why the head tail is 1/2. If this is not a fair coin, then the probability will be based on what is the chance the head occur, what is the chance tail occur, but the concept still will be the same. So this one is kind of interesting. So the last two is kind of interesting problems here. All right, hope that you enjoyed this very classical, tossing the coin probability problem. And have a good day, and I will talk to you in the next time. Let's work on another fun and interesting probability problem. All right, have a good day. Okay, bye.